Good morning students, myself Vaidegi working as assistant professor in Sri Muthukumaran Institute of Technology. Today the video lecture is from the subject CEC 34 Analog IC Design. In today's lecture we will discuss design for testability known as DFT. Specifically we will focus on ADAC techniques used to improve the testability of digital circuits. These techniques help engineers detect faults more easily and reduce testing time in VLSI systems. The learning objectives: at the end of this lecture, you should be able to define DFT, explain why it is needed in modern digital systems, understand the concepts of controllability and observability, and describe several ad hoc techniques used to improve circuit testability. First, we see about the introduction to the design of testability. As integrated circuits become increasingly complex, testing then becomes more difficult. Design for testability is an important approach where testing requirements are considered during the design phase itself. Instead of testing being an afterthought, features are intentionally added to make fault detection easier and more efficient. Next, we see about the need for design for testability. Modern VLSI circuits may contain millions or even billions of transistors. Accessing internal nodes directly is often impossible. Without DFT, generating test patterns and identifying faults becomes extremely difficult. DFT helps overcome these challenges by providing better access to internal circuit states. Testability concepts. Two key concepts in DFT are controllability and observability. Controllability refers to how easily we can force an internal node to a desired logic value using external inputs. Observability refers to how easily we can observe the logic value of an internal node through circuit outputs. A circuit with high controllability and observability is easier to test and diagnose. Next, we see about the ad hoc DFT techniques. Ad hoc DFT techniques are informal methods used by designers to improve testability. Unlike structured DFT methods such as scan design, ad hoc techniques are customized for specific circuits. They are simple, cost effective, and often used in small and medium sized designs. Next, we see about the improving the controllability. One way to improve testability is by increasing the controllability. Additional control signals such as reset, set, or initialization inputs can force internal nodes into known states. This makes it easier to test different parts of the circuit and detect faults. Next, we see about the improving observability. Observability can be improved by adding extra outputs, test points, or monitoring circuits. These additions allow engineers to observe internal signals that would otherwise be hidden. Better observability leads to easier fault diagnosis and faster debugging. Next, we see about the partitioning larger circuit. The large circuits are often difficult to test on single unit. Therefore, designers divide them into smaller functional blocks. Each block can then be tested independently. This approach simplifies testing and helps isolate faults more effectively. For example, a processor can be divided into ALU, memory unit, and control unit for separate testing. Next, we see about the bus access and multiplexing. Multiplexers can be used to route internal signals to output pins during testing. This technique increases observability without requiring a large number of additional output pins. It is widely used in microprocessors and complex VLSI circuits. Next, we see about the initialization and reset circuits. Before testing begins, it is important to place the circuit in a known state. Reset circuits perform this function. A power on reset automatically initializes the circuit when power is applied, while global and local resets help prepare specific sections for testing. Next, we see about the advantages and limitations of ad hoc DFT. Adapt techniques are attractive because they are simple and inexpensive to implement. They improve fault detection and reduce testing effort. However, they are not standardized and rely heavily on designer expertise. As circuit complexity increases, structured DFT methods become more effective. These are the summary points. Hope you all understood the concept. Thank you.